Welcome back my dear friends to Learn with Akash. Today I am here to solve some questions under this theorem 6.8. So let's begin. In my previous video we have learned what is theorem 6.8, its statement and its proof. So now what we are going to do is, using this Pythagoras theorem, we are going to solve the questions. So let's see the first question. So here is our first question. Prove that 3 cm, 8 cm, 6 cm are sides of a right angle to triangle. So here they gave 3 sides or 3 measurements telling that these are the sides of a right angle triangle. But now they are asking us prove that it's a right angle triangle. So for that we'll just draw a right angle triangle over here. Example over like this. Okay. So we'll just name it as A, B and C. So it's right angled at the point B. So always the biggest number is gonna be our hypotenuse. So we'll keep, what is the biggest number over here? 8. So hypotenuse is equal to 8. And this other two sides, it can be either this side or that side. It's based on the question or the figure. But here we are constructing the figure. So we can just keep the adjacent and the opposite side anywhere. So now we have everything. Now they're asking us, is this a right angle triangle? Are you sure about it? So they're telling us to prove it. It's a right angle triangle or not. So what we can do? We can just use the Pythagoras theorem, right? The Pythagoras theorem only works for a right angle triangle. So if these sides are a right angle for a right angle triangle, they should be equal to the Pythagoras theorem. So what is Pythagoras theorem? AC square is equal to AB square plus CB square. Yeah, right? CB or BC square. So this is the Pythagoras theorem. So now what is AC over here? It's 8. So A square should be equal to 3 square plus 6 square. Yeah, right? So 8 square is nothing but 64. 3 square is nothing but 9. And 6 square is nothing but 36. So what is 36 plus 9? We'll get it as 45. So 45 is not equal to 64. So they didn't follow the Pythagoras theorem. It's wrong over here. But it cannot be wrong. It just works only for a, yes, it works only for a right angle triangle sides. So these sides are not for a right angle triangle. So let's solve another question. So here is the next question. Now what is the question is, triangle PQR is right angle triangle at point P and M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM into MR. So this is the diagram if they gave. So they are telling us PRQ is a right angle triangle at the point P and they are drawing a line called PM where it is intersecting in the line of QR, which is forming a perpendicular. So PM is perpendicular to QR. So that is in the diagram. So now what they are asking us to show is, they are saying as the PM square. So this PM square is equal to QM into MR. So we need to check whether they are perfect or solving in this rule or not. So here we cannot use the Pythagoras theorem because here what we are going to do is we are dividing these two triangles, right? So let's just leave that. So let's think out of the box. So now what we need to do is, we'll just write. We'll just prove them they are similar or not. So in triangle PRM and triangle PMQ. Okay. So now what we need to do is we'll check what are the similarities between them. So if you closely look, angle QMP should be equal to angle RMP because they are 90 degrees. So angle QMP, this angle should be equal to this angle because these both are 90 degrees. Okay, so next one is one more angle we need to get. So what can it be? It can be angle MPR is equal to angle MPQ, because MP is a bisector of angle P. So there's an angle over here called 90 degree, and I am bisecting this angle through a form like here B is there, means I am bisecting through BM. So what happened? These both angles come into two equal parts, right? Because they are, MP is the bisector of angle P. So it will be 45 degrees. So that is the rule over here. So now if you closely look, now nothing else we can prove, right? So we can just tell that angle PRM is similar to triangle PMQ. Yeah, right? So what we can tell, so we can conclude that QM by PM should be equal to PM by MR. So now what else can I do in this figure? Nothing, right? So but this is not the answer I need. So what can it be? Yeah, if I just cross multiply them, what I'm getting? I'll get PM square, PM into PM as PM square, which is equal to QM into MR. So QM into MR. So I proved it that this triangle is equal to PM square is equal to QM into MR by just showing them they're similar or not. So let's solve another question under this topic. So this is our end of our session, and we have a final question over here, which is triangle ABC is an isosceles triangle right angled at C. Prove that AB square is equal to 2AC square. So now we cannot simply go directly in the proving, right? There's a diagram missing in this question. So they're indirectly telling us to draw the diagram. So let's just draw and see. So it's a right angle triangle. It's a right angle isosceles triangle. So I drew the right angle triangle, and I need to name it as A, B and C. Why C over here? In my previous diagram I drew B over here, right? Why? Because in the question they're telling us triangle right angled at C. So it is right angled at the point C. So the right angle should be here. So what will be the Pythagoras theorem over here? It will be like AB square is equal to AC square plus BC square. Yeah, right? It's totally different. If we didn't write the diagram, or if we didn't do the diagram, what would happen? We would have assumed that this will be like AC will be the hypotenuse and AB square will be like an adjacent or an base. Yeah, right? That is the important of drawing a diagram. So don't forget to draw a diagram even though they didn't give the diagram. That means if they didn't give a diagram, indirectly they are telling us to use the diagram. That's it. Okay, so we'll just write them. So AB square is equal to 2AC square. So our hypotenuse is going to be AB square. So what is the speciality of an isosceles triangle? Any two sides are going to be equal, right? And hypotenuse cannot be equal with an adjacent or a base. Because in the beginning itself I told hypotenuse is always going to be the larger number. So if I am having like this, where this is 8 and this is 8, so I cannot consider this line as an hypotenuse, right? So it will be wrong. So what should I consider it as? I should think that it will be adjacent will be equal to the base. Yeah, right? So what is the adjacent over here? Which is nothing but AC. AC is equal to BC. So we'll just write the Pythagoras theorem, which we wrote over there itself. So the Pythagoras theorem says that AB square is equal to AC square plus BC square. So we have proved already that AC is equal to BC. So instead of BC over here, I can also write AC square because I didn't change anything, right? So AC square plus AC squares gives me nothing but AB square is equal to 2AC square. So I have proved it. They just gave me a diagram. They didn't even give us a diagram. They just told us it's an isosceles triangle and it's a right angled triangle. And they just tell me to prove it, and we just proved it by how? We just used the Pythagoras theorem by drawing the diagram first. Then we just draw the Pythagoras theorem. Then we came to know the speciality of an isosceles triangle. Then we executed it. Then we just replaced the value and added. Then we got our answer. So at last, don't forget to write hence proved. Okay, so thank you for watching my video. If you like it, share to others also so they can also be stronger in this topic. Thank you for watching.